So the next presentation will be done by myself and Thomas. Thomas has a few pre-recorded demos that are being done, just so we don't have to change between presenters and screens and so forth to simplify the process. So this session or this presentation will be on data-driven websites and interactive data visualizations. So there are many forms of dissemination, many different ways that data and information can be shared with users. Some of these methods are pretty much out of fashion these days. You know, things like the diskettes and CDs and so forth, no one uses anymore. But nowadays, things like social media are becoming more and more popular, and a high proportion of the information that people are gathering is coming through social media on a daily basis. Here are some examples from some of our national statistics offices. The Tuvalu NSO has some information on their website on the left-hand side, some key statistics that are displayed to users. They also have a graph, a visualization on the right-hand side that's looking at imports and exports of their data. The Kiribati National Statistics Office has an online app for provisional census figures, which is actually an example of something that's not simply displaying static content, but in this case, actually pulling information out from a database that can be summarized and visualized. And the New Caledonia National Statistics Office actually fairly recently released a version of PopGIS 3 that has census data for the country. And so this is an example of a database that has a spatial interface that users can explore their data through. So there are three examples, very quick examples of where data is being disseminated through national statistics offices. For this presentation, as I mentioned, we're going to be concentrating on data-driven websites and visualizations. So this also includes, obviously, the .stat database that Dennis was referring to, more generically or more generally the Pacific Data Hub itself with the search catalog, and also things like Power BI and other tools for dashboarding of information. Here I've put up a few points in regards to effective web design. They're deliberately grayed out though, because I don't want to concentrate on them. However, what is highlighted is that we want websites to be user-focused, whether that be the content on the website or the structure, the layout of the website. We need to be thinking about our users. And in the context of what we're talking about today, we ideally want our websites to be data and content driven. We want to create stories with our data. We want to have a central document library and a central database that is a one source of truth, so to speak, as Dennis was referring to, that then drives visualizations and drives content on websites. And ideally, we want our visualizations to be interactive so that the users can explore a little bit themselves. So coming back to those first points that I highlighted, we want to know what users want. We want to find out what users want, sorry. Looking at this diagram in the middle here, what you think users want and what users actually want are not necessarily the same thing. In fact, they're often not the same thing. And we need tests to reveal what users really want. Here in the Statistics for Development Division, we ran what we called a user focus survey in 2017, prior to redesigning our website, to get a better idea of what users really wanted. And very quickly, and I won't go into this in detail, but one of the questions that we asked was around the dissemination products that we had at the time, and asked users to rank in order of preference which of those products they found the most useful. And this was a very valuable exercise. It allowed us to see things like the PopGIS mapping application was very popular. Downloading microdata was very popular. An open data portal, which is actually on the next slide, is something that didn't exist, but we asked how valuable users thought that something like this would be. And 98% said it would be at least somewhat useful, but then a large majority, so about close to 80%, said that it would be very or extremely useful. This was before the Pacific Data Hub even got set up, and before the .stat indicator database was ever launched either. What's also important is to design, to test, to release, to get user feedback. And as part of this process, we also did some profiling of different users. That these are deliberately small. Yeah, the idea is not to read the texts on there, but we sort of profiled a specialist user. We profiled a fact finder, and what's the process that they would go through when they were looking for data on our website. We mocked up the new pages on our website that you can see on the left-hand side. And one of the things that we found from users was they wanted topic pages and they wanted country pages to look at data to do with a topic and data to do with a specific country. And on the right-hand side of each of those mock-ups, you can see what the actual pages look like today. Now, I didn't want to go into that in too much detail. The part that's more important here is having a website that's data and content driven. So using dedicated databases and document libraries for data and content, which then feed the websites and applications. So the idea of having data stored in one place that then feeds a graph, that feeds a map, that maybe feeds different types of graphs is the concept behind something like the .stat database. The diagram on the right is a little bit small, I apologize, but sort of in the top left corner of that diagram, we have the STD website. And we can see the linkages between these different systems that are feeding data into that website. So we have a digital library, which is where we have our documents. We also have the .stat database that feeds the STD website, that also feeds the Pacific Data Hub. We have the microdata library that's feeding the Pacific Data Hub that we're using to extract data, as Dennis mentioned, that goes into the data to the .stat database. And to hone in a little bit on an example, our website is using something called Drupal. The CMS that's used is Drupal, and we've developed a plugin that can be used on Drupal, but also on WordPress websites, which are used by many of the national statistics offices in the region. And so at a very high level, what this essentially does is it connects to the .stat database and pulls data into a data object in Drupal that then feeds blocks or visualization blocks. And so those little charts that you can sort of see a representation of on the right-hand side of that diagram. And now a visualization demo is going to be displayed that's been pre-recorded by Thomas that explains this in a little bit more detail.
Good morning all. I will try to show you how those blocks in Drupal works and how they are linked to .stat datasets. So here we are in the .stat Explorer and we can see the population projection dataset for Vanuatu in 2022. We have the data for each groups of ages and for both men and women. And now on the SDD website, if we go in state by country and have a click on Vanuatu, we can find the population pyramid with the exact same data. It has nice interaction available, and we can also have a click on play to display the whole time series projection. And this component is directly linked with the .stat dataset. In this way, every time a new data is added to the .stat database, it is directly reflected on this page.
With modern technology, visualizing data has never been easier. A few clicks of the mouse can more or less instantly turn a huge table of raw numbers into a visually appealing and easy to interpret diagram. Graphing data provides a high-speed shortcut to creating understanding and getting your points across. Many of the visualization techniques of today were invented during the Industrial Revolution, with the field making large strides in the mid-19th century. What may seem simple and obvious today, such as a bar chart or a line graph, would have been strange and unfamiliar to someone 200 years ago. This image is a little bit hard to see, I apologize, but some of you may recognize it. And this is a map that was produced by John Snow, who was a medical doctor in 1854 in regards to the London cholera outbreak. And at the time, not a lot was known about cholera. And what John did was he went and plotted on a map of London the locations of the water pumps and also the locations of where people were the outbreak was taking place, so infected cases. And he noticed that there was a concentration around where there's the little red circle. And what he did was he removed the pump handle, and they found that the cases in that area dropped. And that's when they first determined that cholera was a waterborne disease. So this is a very early example of where a spatial visualization was very successfully used. And this is talked about in a lot of textbooks today. Another good example is from Florence Nightingale, who is considered to be one of the pioneers in graphical representation of statistics. Nightingale made several studies of the sanitary conditions in Crimea, India, and the UK, and used charts like the one that's displayed here in lobbying for reform. Her work had great influence in the Public Health Act of 1875, which is actually credited by some as increasing the life expectancy in the UK by 20 years. So what is data visualization? Our eyes are drawn to colour and patterns. As we see on the left-hand side with this map of Vanuatu, the red areas stand out, and they're obviously higher in something than the other areas which are lighter in colour. And our culture is visual, now particularly in the Pacific, with tattoos and so forth that are used to depict a story. When we see a chart, we quickly see trends and outliers. And it's self-explanatory, really. A big spreadsheet of data is very difficult to make any sense of. Data visualization is also storytelling with a purpose. And I really like this example, in fact, using Lego blocks, where you can have a bunch of Lego blocks that can be sorted, that can be arranged, that can be presented visually, and then can be built into a house that tells a story, and can even then be useful and used to create a box or some storage or something like this, which takes the example even further, I suppose. And there's a range of different types of visualizations that can be used. This chart or this diagram on the right-hand side is a nice resource to determine which, I guess, standard chart can be used to visualize data. But then we've also got spatial visualizations. We've also got an infographic like the one on the left-hand side that comes from Fiji. Visualization is certainly necessary for big data. There's way too much data to interpret otherwise. And here are four quick examples, random examples that show where big data is being visualized. And you can only imagine what it would look like to see some of these in an Excel spreadsheet, which is probably too big, or even in a database. HiCharts is the JavaScript library that we use for the visualization on the SDD website. Also, the example that Dennis was referring to in regards to the COVID data is using HiCharts. There's a whole range of different visualizations that can be used as part of this HiChart library, which is actually free to use as well. Now there's going to be a pre-recorded demo as well by Thomas in regards to the SDG dashboard.
Thank you, Phil. Now let's have a look to the SDG dashboard, which we can find on the Pacific Data Hub website. This page has some interesting visualization components, like this chart here, which is powered by iChart.js, and also with this progress wheel here, made with another JavaScript library called the D3.js. We can see here the different goals and the progress made by countries. You can change the country here, and the whole wheels gets animated. And now I want to show you what's going on SDG 15 page, which has a lot of other visualization and show the visualization capabilities of iChart.js. We can see here a bar chart, which displays the land area covered by forest for every country. And if you click on one country bar, you can get the whole time series of the land area. And you can go back to countries and select another one, and you can see the whole time series here. Another interesting capability of high charts is, of course, being able to display line charts. Here we can have the average proportion of terrestrial key biodiversity areas for each country, and we can filter, highlight at least the specific line for a country. And we can also have these nice interactive features like being able to showing details of each point. Finally, another type of chart is displayed at the bottom of the page. It's a semicircle donuts chart, and we can also have with this nice interactive capabilities with highlighting specific areas of the chart. All these iCharts components are directly linked to the pdh.stat explorer and data, and we can go back always with all the components. We can go back to the original data with this link here. Okay, and last word I was willing to share with you is that all these components are displayed on Drupal or WordPress websites thanks to plugins we developed at SDD, and we can share it with you if you're interested in, so don't hesitate to reach us or ask questions about it.
So now we move on to dashboarding software. And so you've already seen how we can essentially embed individual visualizations in websites using in this case, the HighCharts JavaScript library that we use. But there's also a range of dashboarding software, and many of you would be familiar with Power BI and Tableau probably, but there's many others. Now we're going to concentrate on Power BI because this is the main product that we're using here at SBC. And so very quickly, there's a few slides here that show you the steps to getting data from the Pacific Data Hub.stat into Power BI. And the first step is there's actually a SDMX plugin that's now part of Power BI that's recently been integrated in the most recent release that can be accessed when getting data by searching for SDMX. So that can be added. Then you need to go to .stat, look at the table or open the table that you're interested in, go to the API or the developer API query area and copy the string that's in the top left here. That then gets copied into this SDMX connector. There's a few other settings that you can set. It then extracts that data, allows you to load it directly or to transform the data. And here it's just been loaded directly, and you can see in Power BI, we now have access to that data that can then be visualized. And here's a very quick pre-recorded demo by me that shows a dashboard that's been developed using Power BI. This is the International Merchandise Trade Statistics Power BI dashboard. This dashboard gets all of its data from pdh.stat and uses the SDMX plugin that I just showed you. We have a range of pages in this dashboard, including this one that looks at trade overview, where we can filter by country and by year. If I change the country from Fiji to Kiribati, it reflects that in the two charts. I can select a year in my left chart, which then reflects in my right chart. And so they're linked in a way that we can't do easily with HighCharts, as we've showed you, or Thomas has showed you in previous examples. We can also look at flow of trade, and I apologize, I have a slow connection while I'm recording this, and so it doesn't display as quickly as I would like it to. But here we have flow of trade being exported to Fiji as the importer. And so we can see the volume of trade going from Singapore to Fiji, Australia to Fiji, and so forth.
And we can also isolate some of these and or filter in the right-hand chart. We also have different types of visualizations that are quite interesting, like this one where we're looking at flow of trade from an importer to an exporter, and I can also go and isolate an importer, for example. In this case, I can look at Fiji and I can see all of the exporters exporting to Fiji. Likewise, I can go and isolate an exporter and see who's importing in the Pacific from that exporter. This is for data that has been reported and we have access to and are storing in our database, of course. This doesn't necessarily include all available data. We also can visualize some of this data on a spatial map. And so here we're looking at principal exports, including re-exports of Pacific Island countries and territories. And when we're here, we're looking at New Caledonia, who's actually got the highest number of exports at $789 million in 2020, in this case of base metals and articles related. And I can go and filter and zoom in on New Caledonia.
And so lastly, there's a gentleman by the name of Alberto Caro, who's a journalist and designer, and the Knight Chair in Visual Journalism at the School of Communication of the University of Miami. He has been the head of information graphics and media publications, at media publications in Spain, Brazil, and other places. This gentleman is very, very well known when it comes to presenting data and making effective visualizations, and there's a whole range of material that can be viewed through YouTube and online courses and so forth. And he's got 4 key principles that I wanted to just pull out here when it comes to effective visualizations. One of them is adding context, that simply a visualization with nothing around it, with no explanation, with no context, isn't really maximizing the value of that visualization. You also need to look for patterns, but don't oversimplify, which is self-explanatory. Be creative, but also skeptical of creativity, so stay focused on the facts, which essentially is focusing on what matters. Thank you very much. That brings me to the end of the presentation.